Oh no. I mean, this how it is. Hopefully you guys turn around. I don't have graphic without notebook paper, copy paper. I will tell you the history of every single student that gone through here. And none of them are quitter. None of them. Emilio went to Stanford. He actually failed my volume test, and I cussed him off. I really cussed him off. I said, "Get the hell out of my classroom." But the kid is like, "Yeah, don't worry, Mister. I got you." He's alpha. Like you can tell he's alpha. He just says, peace out, but don't worry, next test I got you. Right? And he come back, he will score 100 on all the tests. He does so calmly without doing any homework. That's how badass he is. Now, I don't think you guys are like, he's built different. I don't think you guys are like that. He didn't do homework, but he'll help everybody doing homework. So the way he justify he doesn't do homework is like, Mr. Yeah, I already helped like 20 students how to do question 20, question 28. I don't need to redo again and copy on the paper, which is I say, oh yeah, that's fine. I'll let you get by. So let's speak of the let's speak of related rate. Related rate is a big topic. Unfortunately, last year there's only 2 questions on multiple choice, which is worth 2.4 points out of 108, which is I thought it's kind of sad, but I think calculus, the most important thing is related rate because that's what lead to study about other things, the rate of changing about many other things. So I'm gonna start with a comb. Oops, I'm not showing screen. My bad. Let me show my screen. Okay, so I will start with a comb. It's not a comb. The comb looks like this. And I will start by Martin. I did grade your paper. She left. Did Martin left? So there's water inside this cone. Okay, and this is water here. And the water is dripping out here. Okay. Let me ask you. Inside this cone, what is changing? Volume of water, good. So volume of the water is changing. So in terms of math, we're gonna call that dV dt. Remember D stands for delta. So that means changing a value over changing time. And this is called rate of change. It's also known as how fast the volume changing. How fast the volume changing. What else is changing? What is it? Weight is changing. Good. That's a very good thinking. Weight is changing. That's definitely different than what I expected. And that's definitely changing. Yes, that's true. But here we're not considering that. But Nicholas,
the circumference of the water line changing?
they do changing, but it's gonna affect, but it's nothing to do with the relationship I have. But surface area they cause other things to change. So think about that. Yes.
The volume of the empty space.
Huh?
Volume of the empty space.
Okay, that's changing, but it does not contribute to what will be the volume of the cone. Think about volume of cone formula. You guys should know the volume of cone formula. Yes? The height is changing. Thank you. So dH dt is how fast the height changing. And one more thing. Radius. Okay, some people said radius would be dr dt. That's how fast the radius is changing. Now, why did I didn't say anything about weight? Weight does change, but I hear we don't have a density. With and that could be involved with different thing, different situation, and the surface area does change, but doesn't not do anything to volume equation of a cone. Anybody can tell me what's volume equation of a cone? What's the volume equation of a cone? It's 1/3 of a cylinder. Good. PR squared H. No. What happened is here, I'm going to take a derivative with respect to time. And if I take a derivative with respect to time, it's different. It's like implicit derivative. But it's not implicit derivative d to the dx. This is the first time you're taking derivative with respect to time. Actually, second time. You did the same thing yesterday on the value on the projectile equation because the variable is t squared. It's negative 16t squared plus, I don't know, 144t plus 576. And you take a derivative with respect to time. That's how you get, negative 32t when you find the velocity of impact. Now, this time is the first official time that we're taking derivative with respect to time, which is d to the dt. What's the difference compared to before? Remember, when you take an implicit derivative of x squared with respect to x, you're going to get 2x. If you take d to dx of y squared, you're going to get 2y dy dx. Do you remember that? 2y dy dx. So this same thing, but except everything's a variable now. R squared is a variable, h is a variable, and every time you take a derivative with respect to that, there's a chain rule involved. There was an implicit derivative involved. So what happened if you take a derivative volume with respect to time? What'd you get? What'd you get? Hello?
In respect to time.
Yeah. What is it?
Time?
No. In respect to time. What's volume? Take a derivative with respect to time. It's right, very, very simple. It's right in front of you. What is it? dv dt. Thank you. And that's that. Simple as that. Like, you take a derivative of y, you're going to get dy dx. But except now it's dv dt. Are we okay here? Now I'm going to take a derivative of 1/3 pi. And then I'm going to take a derivative of r squared h. Now there is a product rule. Why is a product rule? Because r squared times h. But remember, there's an implicit derivative also involved here. So we're not solving. We're just taking derivative with respect to time.
Okay.
So what's the derivative of r squared h?
2rh.
R squared dh dt to r dt h.
That's actually perfect. Good job. So if I take a derivative r squared, it's going to be 2r dr dt h. Does that make sense? Plus leave the r squared alone and just take a derivative of h. Then it's going to be dh dt. It's kind of like implicit derivative. Now, everything you have to get. Like y squared before, you got 2y dy dx, but x squared is just 2x. But in this case, you're going to get d to the dt for everything that you take a derivative risk. So there's how fast the volume change, how fast the radius changing, how fast the height change. They have an equation that relate to each other. So when you get to this quick question, you're going to be like, oh, okay. Yeah, I know how to take a derivative. But what would it be a question of? The question is going to look like something like this. Okay, so I don't want to copy this whole question, so I'm just going to be like copy and paste. Copy. And paste. I think I did graded. It's okay. So let's look at this question. A pebble is dropped into the lake. The radius of all the ripple is increasing at a constant rate of 1 foot per second. When the radius is 4 feet, at what rate is the total area A of disturbing water changing?
What is the last thing you want to say? Disturbed.
Water changing. So if you drop in a thing into the lake, it's gonna form something like this, right? It's gonna form a ripple. Right. I mean, this ripple is not exactly even. Sorry, I tried my best. Okay, something like this. It's gonna keep on getting wider and wider and wider, right? So that's the outer ripple. It tells you that the outer ripple is increasing. Keywords increasing. They can be, I mean, decreasing if you film it backwards. Yeah, but at a constant rate of 1 foot per second. 1 foot per second. When the radius is 4 feet, at what rate is total area A disturbing water changing? Okay, so let's look at this question. What kind of relationship I should use in here? And why? What kind of relationship I should use here?
dr over dt.
Well, it does have, but what kind of relationship, like a formula I should use here?
The area of the circle, so I r squared.
Establish relationship, right? So what's the relationship between A, R, A and R? So the area of circle is actually perfect. A equal to pi r squared. So establish a relationship. The relationships is A equal to pi r squared. Second thing I'm gonna do is, what is giving? What is giving to you?
The rate of change of in radius.
In terms of calculus, though, you're right. But what's in terms of calculus mean? dRdt, good. That's equal to 1 foot per second. Pay attention to the unit. The unit can help you. 1 foot here is foot to the first power. So it means one-dimensional. So it has to be just a one-dimensional thing. So which is radius or the length or width or things like that nature. So 1 feet per second. So what is giving in terms of calculus? It's dRdt. Not just how fast the radius is changing, is the changing radius over changing time. The rate of change of radius with respect to time. Am I going too fast? Third things. What is this question asking? What is asking in terms of calculus? Read the question. What do you think is asking in terms of calculus?
Area disturbed, water changing.
Which is in terms of calculus, what would that be?
D dA over dt.
dAdt is good. Right now, only Rebuff is thinking. Other people need to think too. Now, dAdt is equal to a question mark, which is we don't know, right? We don't know what dRdt is, but also we're going to show you a new notation. The new notation is this straight line. There's no name for that straight line. That straight line is like kind of like talk about is a when what? This is something we haven't used yet. R is equal to 4. When R equal to 4. When R equal to 10 is different than when R equal to 4. Remember, the outer rim of the circles, the more outer rim, the more area is changing because the area is bigger. Fourth, take a derivative with respect to time. So take derivative with respect to time on the relationship equation. And that's what I call a related rate, because I have A equal to pi r squared. Let's take a derivative of A with respect to time. dAdt, good. Is equal to what?
In parentheses, 2r, no, 2r dr over dt.
Okay. Now, you already know dAdt is what we're asking, but we also know that r is equal to 4 and dRdt is 1. So it's 8 pi foot second per square per second. Why is foot second? Because the area. Area is feet square. And also r is feet, and dRdt is feet per second. So feet times feet is going to be feet square over second. Martin, you copy this down?
How's it feet per second? That's dr over dt equals 1.
This is related rate. Supposedly, yeah.
How's it feet squared?
Because 4 is feet, and dRdt is feet per second. So feet times feet per second, so it'll be feet squared per second. The unit gonna give you a big hint about what the calculus means. This should not be too hard. Very simple, very direct, very forward. The related rate is gonna scare you, but it's nothing scary. And that's what deals some crazy problems like how fast your shadow is growing. Yeah, we are gonna do that on Thursday. Wait, Thursday, yeah. So here's the question to you. The air is being pumping into a spherical balloon at a rate of 4.5 cubic feet per minute. Again, cubic feet should be written like this. I can write it like this. That gives you a good clue what is changing. Find the rate of change of radius when r equal to 1. Okay, let's analyze this. What will be the relationship I'll be using here? Area of a sphere, good. That's a good start. Okay, what do you think 4.5 feet cubed per minute is? In terms of calculus,
The
remember the unit's gonna give you a good clue of what is it?
is that v equals 1 or r equals
When r equal to 1.
1? Okay. Is that volume? So dv over dt?
What is dv of dt?
The rate.
What is it?
Changing volume. Changing volume.
Okay, but what is it here? What number is it?
4.5.
Okay, good start. Go ahead and try it. It'll be easier to do calculation of 9 over 2 instead of 4.5 because you don't have calculator for this test. So it's 9 over 2.
Is it volume of the sphere?
What?
Volume of the sphere?
What is volume of sphere?
Like the relationship.
Okay. Yeah, you have a volume and you have a radius. I said dv dt is better to use 9 over 2. Now, why do I know it's dv dt though? Okay, I'm gonna do it really quickly. This is giving to you, so it's 4.5 in the feet cube per second. That means per minute. That means the volume is changing. So feet cube, because feet cube is the only volume. So dv dt is equal to 9 over 2, which is 4.5. And the feet cube per minute. Now, what will be the relationship here? Volume equal to 4 third pi r cubed. And what are they asking? They're asking for dr over dt equal to question mark. So all we gotta do is take a derivative. They pick the right time to do that. So I picked the right time to do that. Sorry about it. What did I say over there? Okay, so I only take a second. I can take a derivative with respect to time. I'm gonna get dv dt is equal to 4 pi r squared dr dt. And dr dt is what we're looking for, so then I just evaluate for that. So dv dt is 9/2 is equal to 4 pi times 1 square dr dt. So I just moved 8 pi to the other side, so dr dt is equal to 9/8 pi, because I divide by both sides by 4 pi, so that is going to be 9/8 pi. And this one is going to be feet per minute, and that's how fast the thing's changing. So there we go.
Here in the cube again.
How do I get rid of what? Because you divided by the rate of changing, and you also divided by oh no, you divide by feet squared, because 1 is square,
Oh, okay.
and the feet squared is going to cancel out, so it's going to be feet per
Question, I know it's not much, but this I got both these wrong, but I think B over 1.
Yeah, that's fine. But yeah, gotta do better than that.
I mean, it wasn't tough, but like I look at my answers and like that's what I was doing. I was looking at the right answer, and like a lot. The first one, I can't believe just didn't know like how to do that. I knew how to do it, but it's just like the bottom one, like to the third power with the radical.
Not yet. This is one of the homework questions. Huh?